Welcome to my channel. This is the part 3 of linear algebra MTE 2. In this video, I'm going to continue to solve the previous year question papers. You can go to the part 2 and part 1 and the links are given below in the description box. Thank you. So this is the number 2. You can reduce the quadratic form this much to its normal canonical form. Also find its principal axis. Now look, there is a little bit of difference. This is orthogonal canonical reduction and this is normal canonical form. So there is a little bit of difference. So let's see what is that. And here principal axis you need to find out now. So the same way we will proceed. So this is my quadratic form and there are two variables. So I wrote here xy and xy and then I made the division and then I made the distribution. So here this is vertically x, horizontally x, it is x square. This is xy, this is xy, this is y square, right? So the diagonals are x square and y square. So coefficient of x square is 8, so I wrote it. Coefficient of y square is 5, I wrote it. Then there are two places of x and y, so minus 4, I divided it into two symmetrical parts, minus 2 and minus 2. Then you know to apply the characteristic equation as I have shown in the previous question. The same thing, look, you can verify your answer. So this is the equation I got. Lambda square minus 13 lambda plus 36 is equals to 0. After factorization, I got lambda minus 9 and lambda minus 4. That means the values are 9 and 4. So I got two eigenvalues that are 9 and 4. So to find out the eigenvector, I need to replace the 9 in this matrix, right? In this matrix. Okay, so I have to replace it twice. First for the value of 9, then for the value of 4. Okay, so what do you mean by orthogonal canonical reduction? I already told you that canonical means the values of the lambda will be the diagonal element. So here 9 and 4, so I just wrote here 9 and 4 and others are 0, right? So how can I represent this? I can represent, look, I took y1 and y1 to other variables. Okay, so look, if I will represent like this y1, y2 and y1, y2, this will be y1 square and y2 square. This is y1, y2, y1, y2. So whatever the coefficient is here, that is of y1 square. So 9 y1 square and this is 4 y2 square. So this is my orthogonal canonical reduction. But what I need to find here is I have to find the normal canonical form. And what do you mean by normal canonical form? In the normal canonical form, the coefficients are either plus or minus 1. So here the normal canonical form z1 square plus z2 square. Just I told you that the coefficient should be plus 1 or minus 1. Okay, so here whatever that 9y1 square has been given, so I just directly wrote it z1 square, and whatever it is given I just replaced it with z2 square. So after that I can find what is z1, 3y1, and z2 is 2y2. Okay, now I can replace what is z in form of y. Look, z is 3 times multiple of y1 and 2 times multiple of y2. So I just wrote it 3 0 0 2 y. Then as you know, you have to replace the eigenvalue in the matrix xy and 0 0 to form equations and find the solutions. Look here, I found out the solution. So the eigenvector I found here is 2 1. Okay, and I wrote it column wise. Then again for lambda is equals to 4, I have to again find out another two equation and I have to find another eigenvector. So here I found out two equations. Again they are dependent, so I just took here x is equals to 1. You can take anything, right? So I got y is equals to 2. So this is my another solution and this is my eigenvector. And look, this is my model matrix. And what do you mean by model matrix? It is just the eigenvectors represented in column, right? And what is the orthogonal matrix consist of? Orthogonal matrix consists of normalized eigenvectors. So I just found this two. Okay, so this is my first eigenvector 2 and 1 and divided by square root of first element square plus second element square, like that here also. Now I got the normalized eigenvector. Okay, so what is the orthogonal matrix? This is this 2 in the column wise I just represented it. And what is the principal axis? I told you before also, whatever the variables given in the question, that one is equals to, this is my orthogonal matrix and this is another two variables I can take. So this is the third question. Find the orthogonal canonical reduction of the form this much and its principal axis. Look, this is very easy. Okay, one more thing I forgot, that these are the marks Okay, and these are the year and months. Okay, so this is the same thing, you can find it out. Just I'm just showing you the answer, you can do, and you can just do tally with my answer. So this is the matrix I wrote, then characteristic equation, then this is the equation lambda cube plus 13 lambda minus 12 is equals to 0. So here in this kind of question I have to always use substitution method. So after substitution I found out that for lambda is equals to 3, this much is getting 0. So 3 will come this side, lambda minus 3 is equals to 0. That means lambda minus 3 is one of the factor. After that, to find the another factor I have to divide it. So I divided it and I found this much. So this and this again I have to factorize this much. So lambda minus 3 is equals to 0, lambda is equals to 3, and after solving this I got lambda is equals to minus 4 and 1. So 3 eigen values. So after that I have to replace the eigen values to find out the eigen vectors. Okay, so here 3 variables are there, right? So I found out the equations like this: y is equals to 2x, and this is second equation, but I put the value of y here. This much is the second equation. Z is equals to 3x, 3y minus 2z is equals to 0. So again they are dependent. I can find out this one of the solution 1 2 3. This is one eigenvector. Likewise I replaced the another eigenvalue and I found out the second eigenvector 1 minus 5 3. So this is the solution, second eigenvector. Then again for the third one I found out the solution, and eigenvector is minus 3 0 1. So this is my model matrix. Then I found out the normalized eigenvector like this. So these are my normalized eigenvectors. I represented it. And what is the principal axis? This is the variables of the question given, the orthogonal matrix and any other variables. Now what is the orthogonal canonical reduction? What are the eigenvalues? First one is 3, so 3y1 square. Second one is minus 4y2 square. Third one is plus 1, so plus y3 square. Okay, so this is the new variables where this can be changed. So we can also tell this as the coordinate transformation. As I told you in the before question also, I can change the x is equals to 1 by root 14 y1, 1 by root 35 y2 minus 3 by root 10 y3. Likewise I can change y in this variable in the form of 2 by root 14 y1 minus 5 by root 35 y2 plus 0. And I can change the z as 3 by root 14 y1, 3 by root 35 y2 and 1 by root 10 y3. So this is the fourth question. Find the orthogonal canonical form to which the following quadratic form can be reduced. Also obtain a set of principal axes. So this is the same. Look, you can find the principal axis, you can find the orthogonal canonical form. So let's just see. So first I represented this in matrix form. Look here, the variables are x1, x2, x3. So x1, x2, x3, x1, x2, x3. Then I found out everything. Then I just put it. Okay. Then you can find the characteristic equation. After that, this is my equation I got. Then I have to use the substitution method. So for lambda is equals to minus 1, I found this as 0. So minus 1 will come this side, plus 1. So this is my first factor. Again that factor is factorizable. So again I found out the factor. What I got, the values of lambda as minus 1, 2, 2, right? So for this minus 1 of eigenvalue, I have to find the eigenvector. So I just put it in that matrix and I found out the equations. I just found out the equations and this is the values. Look, x is equals to minus y, z is equals to minus y. So I just put the value of y as 1, then x became minus 1 and z becomes minus 1. So this is my solution, first vector. Then for, look, here the eigenvalues are 2, 2, right? That means that if the eigenvalues are same, then the corresponding eigenvector will also come same. Okay, so for lambda 2, these are the equations. All the equations are same. Look here, x minus y plus z equals to 0 everywhere came, hence parallel. Therefore, the variables are dependent. So, I just took any two possible solution. Look, here I took 1, 1 and 2. You can put it in check. 2, 4, 2. So, I took any two solutions because there are two 2's, right? So, for two eigenvalues, I need two eigenvectors. So, these two are my eigenvectors. So, modal matrix this much and normalized eigenvectors, hence orthogonal matrix, principal axis. Okay, and what is my orthogonal canonical reduction? It is, my first eigenvalue is minus 1, so minus y1 square, second one is 2 y2 square, third one is also 2 y3 square. So this is my orthogonal canonical reduction. So this is the number 5, and again the same thing it has been asking, orthogonal canonical form and principal axis. So let's have a look at this. So again here look, there are same eigenvalues too. Look, I can also take y as 1. So here I took y as t, you can also take it as 1, no problem. So as I took t and I took the t common, so I got minus 1, 1, 1. So here look, I got 0 is equals to 0, that means they are dependent. So any two solutions I found out as the eigenvalues are same. So this is number 6. There is one more question attached to it, that is, after finding the orthogonal canonical reduction and principal axis, you have to draw a rough sketch of the orthogonal canonical reduction of Q is equals to 4. The quadratic form, matrix form, characteristic equation. Eigenvector, normalized eigenvectors, principal axis, orthogonal matrix, orthogonal canonical reduction. One more thing it is there. Finally draw a rough sketch of the orthogonal canonical reduction of Q is equals to 4. Now here, if we are putting some constant in place of Q, then the matrix form. This is the matrix form, right? And what I told you is this x square and y square. These two coefficients will never get changed, but this xy may vary. this is the symmetric division of the coefficient of xy, that is minus 2 root 2 is there, no, minus root 2 minus root 2. But this division can be different, no. I can write a minus 2 root 2 0, I can write it minus 2 root 2 0, or I can write it in any way, right? So the value of q will come this same. If I told you in the previous video that if I am changing this division differently also, the value of q will be same, no. So we don't know that what is the value here and here when q is equals to 4, but whatever the values are here, always this the same will come, minus 2 root 2 xy. So here what happens, the coordinate gets changed. Like look here, this is x and x square, this is y and y square. This coefficient will remain same as it is, right? And what is this x square and y square in canonical form? Remember, these are the eigen values. So look, the orthogonal canonical reduction is y1 square plus 4y2 square. These are the eigenvalues 1 and plus 4. And what is the coordinate transformation? I supposed here that x and y changed into another coordinate y1 and y2. So what is the value of x now? Look, so x is equals to 1 by root 3 y1 minus root 2 by root 3 y2. Similarly, the value of y is root 2 by root 3 y1 plus 1 by root 3 y2, right? These are the coefficients of the diagonal elements, and these two will never get changed. So I wrote it. Look, so given q is equals to this much, okay, so 3x square plus 2y square minus 2 root 2 xy, when it changes into 4, these all will get changed. Now I wrote it, this 2, I wrote it in canonical form, right? And minus 2 root 2, what is the value of x after coordinate transformation? This much, and in place of y this much. Then look what I did, I just changed the x and y into y1 and y2, right? So this is my canonical change, which are the diagonal element, and this is the non-diagonal element. So I just replaced the value of x and y in place of this, which is equals to 4. So after solving this all in this way, I got this much, minus y1 square plus 16 y2 square plus 2 root 2 y1 y2 is equals to 12. Now I have to draw a rough sketch, no? So there are many conditions to draw the rough sketch. Let's have a look at that. So these are the conditions. Look, for ellipse, the standard equation is x square by a square plus y square by b square is equals to 1, where a and b should be greater than 0, and this is the sketch. Just like that, for circle, this is the form of standard equation, and this is the sketch. For hyperbola, this is the standard of equation, and this is the sketch. For parabola, this is the standard of equation, and this is the sketch. For pair of intersection line, this is the standard of equation, and this is the sketch. For pair of parallel lines, this is the standard of equation, and this is the sketch. For pair of coincident lines, this is the standard equation, and this is the sketch. For point conic, this is the standard of equation, and this is the sketch. Every time whenever the question is telling you to draw the rough sketch, you have to always try to form the standard equation, and the standard equation can be of ellipse, of circle, of hyperbola, of parabola, of pair of parallel lines, or pair of coincident lines, or point conic. Okay, so after this I try to convert it into squares. I just made the partitions and I just converted into, look, this is a square and this is a square, so I just bring it to here, so that this square minus this much square is equals to 12. Then I just brought it to this side, so this is in the form of parabola. No, look, how could I know? I just took this as and this as y, so I could replace it that x square by 12 minus y square by 96 is equals to 1. So it is in the form of hyperbola, hence the conic represents hyperbola. Now you can draw any rough diagram like this and just make hyperbola, and you can just make a hyperbola rough sketch like this. Now the next question is, find the orthogonal canonical reduction of the quadratic form this much and find its principal axis, which is very easy. And in the same way, you can just try it out and check your answer here. So next, number 8. Again, find the real quadratic form represented by the matrix this much. So this is given in the matrix form and we have to find the quadratic form of this. You know, this is the place of x square, y square. This is xy and xy if we are taking the variable as x and y. Then also obtain a set of principal x's for it and hence reduce it to its normal canonical form. In the previous questions, we know how to find out principal x's and we know how to find the normal canonical form. So let's have a look at this. So here this will be the real quadratic form. This is my matrix form given and we will do as I have discussed before also to find the principal x's. So this is the orthogonal canonical reduction when I am taking another variables y1 and y2. So this is the normalized orthogonal matrix and this is the principal axis and the orthogonal canonical reduction form is this much. We know that in normal canonical form the coefficient should be plus or minus 1 or 0 diagonal matrix in the canonical form, no? So whatever here is, I have to make the coefficient 1. So I can take root 2 y1 is equals to z1. So this will be z1 square. And I am taking this 2 y2 as z2. So 4 y2 square will be z2 square. So in this way the coefficients are 1 and 1, or in matrix form this is the canonical form. These are the eigenvalue and this is the normal canonical form, right? I can also represent this as z is equals to root 2 2 0 0 y, because look here, root 2 y1 2 y1 root 2 2, this is z, this is y, and non-diagonal element will be 0. Reduce the quadratic form this much to its orthogonal form, clearly giving the transformation being used. Also give a rough sketch of the curve representing this canonical form. So again we have to draw a rough sketch here. So this is number 9. So this is the coordinate transformation. So this is the next question. Again you have to find the orthogonal and normal canonical reduction of the quadratic form 7x square plus 6x1 x2 plus 7x2 square, 7x1 square plus 6x1 x2 plus 7x2 square, and you have to identify the conic represented by this much is equals to 200. Also find the principal axis of the given quadratic form. So this is the quadratic form, matrix form, then characteristic equation. Look, these are the Eigen values, and 7x1 square and 7x2 square, the diagonal element will change to this canonical form. Then x1 and x2, the variables have been changed, so I replaced it with the transformed variables y1 and y2, then solved it and I got this much. So it is in the form of circle, hence this conic represents a circle. So you can just this much, right? This is circle. Thank you for watching my video.